Hi everyone, welcome to Folk Academy. In this problem, here how to find current I naught of t which passes through this branch. So here one current source given, that is e power minus 2t u of t amperes, and having connected two branches are there like this. So here one capacitor, one resistor, here one inductor, one resistor is there. Now how can you find the current I naught of t? By using Laplace transform. This is the problem. Here asking to solve this problem by using Laplace transform. So at the time, so first of all convert this time domain circuit into the frequency domain circuit. So for that, convert every element in the frequency domain. So first of all, I am going to convert the source into frequency domain. So by applying Laplace transform for this information, that is e power minus 2t u of t. So for this, it becomes 1 by s plus 2. Note here, the impedance for a resistor, the impedance equal to resistance only. For inductor, the impedance is SL. For capacitor, the impedance is 1 by SC. So these are the formulas for finding the impedance. So now here replace all values here. So this is nothing but impedance only because Z equal to R. So this is impedance only. This is also impedance. Now for this SL, L means 2, there is 2 S, and here 1 is there, so 1 by 1 S, but 1 by S. Now successfully we convert the circuit from time domain to frequency domain. Now apply node analysis here. So at this point, from this branch the current was entering, and here the current was leaving. So according to node analysis, incoming currents equal to sum of the outgoing currents. So at this node, this is the incoming current, these are the outgoing currents. So let's consider this is I1 and this is I2. So this is I0, take as I0, and this is I. So capital I equal to, this is the incoming current, capital I at this node, and here I1 and I0. It was putting, that is I1 plus I0. Why I am taking I0 means, already asking that is I0 in this equation, in this branch, that is I0. Okay. I1 is here 1 by s plus 2 in frequency domain, that is 1 by s plus 2, that's equal to, now what is I1? So at this point, let's consider there is a voltage V0. So according to Ohm's law, V by Z equal to current I. So here V0 by the impedance is for this branch, that is 1 by s plus 2. So in this branch, the voltage by the impedance of capacitor plus the impedance of resistance, plus here also V0 by the impedance of inductor plus resistance, that is 2s plus 1. So bring V0 common here, then we get 1 by s plus 2, that's equal to, so it becomes 1 plus 2s, bring s upon the numerator, plus 1 by 2s plus 1, so V0 is common. By LCM here, s into 2s plus 1, next class one here, plus 1 into 1 plus 2s upon 1 plus 2s into 2s plus 1 into V0. Here on LHS, 1 by s plus 2 is there. Now bring this term to the LHS, then we get V0 equal to 2s plus 1 upon s plus 1 into s plus 2. Or you can solve like this also. So here 1 plus 2s is there, here 1 plus 2 is there. So bring it outside. So numerator is s plus 1. So s plus 1 by 2s plus 1 into V0. Now bring this term to the left hand side. It becomes like this only. There is no issue. Now we got V0 value. Now how to find the current I0 value? So here I0 means this is the value, that is V0 by 2s plus 1. So use this equation, you will get I0 value, that is I0 equal to v0 by 2s plus 1. Now substitute this function here, then we get I0 equal to 2s plus 1 upon s plus 1 into s plus 2, this is v0 value, upon 2s plus 1. Here 2s plus 1 will be cancelled and reduce 1 by s plus 1 into s plus 2. This is I0 of s. I0 is in terms of s we got, but here we want I0 of t. So apply inverse Laplace transform for this. So but here it is not in the standard form. So first of all convert this into partial fractions. So let us assume this is equivalent to a by s plus 1 plus b by s plus 2. Now take LCM here. So a into s plus 2 plus b into s plus 1. So s plus 1, here s plus 2. On LHS 1 by s plus 1 into s plus 2. So here s plus 1 into s plus 2 will be cancelled on both sides, and it remains 1 equal to numerator a s plus 2a. Now expand this term, that is as plus 2a plus bs plus b. So bring s common in these two terms, we get a plus b into s plus 2a plus b. So here there is no s terms are there on LHS, that is 0s plus 1. So a plus b equal to 0, and constant 2a plus b equal to 1. By simplifying this, we will get a value, that is 1, and b value is minus 1. Now substitute here, then we get 1 by s plus 1 minus 1 by s plus 2. B value is minus 1, that's why I am taking here minus. Now we can easily apply inverse Laplace transform for this because it was in the standard form. So according to Laplace transform, so Laplace transform of e power minus at, thus equivalent to 1 by s plus a. So it was in this form. So for this, inverse Laplace is e power minus t minus of here e power of minus 2t into u of t. U of t is step signal. Just it was indicates that it is a signal. So this is the I0 of t. So this is the required I0 of t for the given problem, and this is the process of simplification. Thanks for watching. Please subscribe, like, share. Thanks.